Hello and welcome. We are looking at Chapter 4, Exploring Numerical Data, and today we're going to focus on center and spread of the data. There are two things that you should take away from this video. The first one is how to identify the mean and the median of a data set and be able to talk about the relationship, and the second will be to be able to calculate range, quartiles, and interquartile ranges of that same data set. So when we're describing numerical data with summary statistics, right, we want to describe more than just the overall shape. And one of the ways that we can do that is looking at the center. Okay, so how far spread out is it from the center? Okay, so when we're measuring the center, we're going to use two different ways. We're going to look at both the mean and the median of the data. So the mean, as you may remember, learning in the past, is where you just take the average of all of the data. So we simply add them up, divide by the number of observations, and that gives us our mean. Now that can be denoted with the X with just a little mark over top of it. Okay, so let's go back to the 2015 AL run scored totals that we've been looking at. So 2019, right, there were 15 total teams in the AL, and this is a list of their data. So if we want to find the mean, okay, we just add up those 15 run totals, divide by 15, okay, and that gives us an average for the American League of 790.6. Now, I also did it for the National League, okay, and we got 773.9. So on first look at this data, it looks like the American League averages, right, a larger amount, so therefore, right, that they score more runs. But there's a lot more to look at than just that. Okay, so first of all, let's take a look at what does that exactly look like with our data. So when we look at the dot plots for the two, what I did was I dropped a little arrow, okay, denoting right on it exactly where that mean falls. Okay, because right, the mean doesn't necessarily mean there's the same number of data points. It means there's the same amount of value on either side, right? So if you want to, you can kind of think about it as that balancing point. You know, if it was a seesaw, you'd want the fulcrum right there so that way balance on both sides. Okay, so the other important thing we look at is the median. Okay, and the median in the data set is just its middle value. Okay, so we just put the values in order from least to greatest. I mean, you can do greatest to least, but we're going to do least to greatest because that's what we need to do for the next thing we're going to look at with quartiles. Okay, so we're just going to do it in that order anyway. And then you literally just get halfway through your data. Now, if you happen to have an even number of data points, you're not going to have a middle data point. Okay, there'll be two in the middle. So you just add the two together and divide by 2 or find their average. Okay, and then that the median is denoted with a capital M. Okay, so if we go back to those same 15 AL run totals, okay, only now we need to put these in order. So, boom, put them in order from my 582 up to our 943. Sadly and unfortunately, I'm pretty sure that 582 is my lowly Tigers. Okay, but if we count across, we have 1, 2, 3, 4, 5, 6, 7, 8, right? Because halfway from 1 to 15 would be 7.5, so that'd be the data point 8, and that puts us right at 769. Now for the National League, if you put them all in order and you count up to number 8, because there are also 15 teams in the National League, you get that there are 774 is the median for the National League. Well, hold on a second. Okay, let's look at a recap really quick. That means that the average of our American League teams, right, was 16.5, almost 17 runs larger, but the median of our National League team is actually bigger by 5 runs. Okay, so that clearly shows that the way this data is spread out, right, is affecting those values. Okay, so our American League is spread out further than what our National League, and our National League is much closer, which if you remember back to the dot plot, right, that does make sense. Okay, so the shape of the distribution, if you remember back, skewed right, skewed left, symmetric, okay, those have a relationship between the means and the medians of the distribution. So when the distribution is symmetric, the mean and the median will be approximately the same. Okay, when a distribution is skewed to the right, okay, the mean will be greater than the median, And when the distribution is skewed to the left, which does rarely happen in sports, okay, the mean will actually be smaller than the median. Okay, so if we look at a histogram for the 2019 Major League Baseball stolen bases, okay, this is one that we looked at earlier. Okay, you could see the median for this, I marked with a little arrow there, is at 4. Well, although half your data falls before that and after that, obviously the data that's after that, since half of it falls after that, there's so much data that's way above, right, 8, which would be double that median. We know that this mean is going to have to be higher, okay, than what our mean is, or than what our median is. And in fact, okay, if we go through and we look at that, okay, and we do the values, we get that the mean is actually 6.7. Okay, and that's because those data points high on the right-hand side, which is why it's skewed to the right. So by being able to identify the shape and center of the distribution, right, that's a great start. Okay, but then we want to look at a little bit more than that. Okay, because if we look at this, right, here are these two dot plots, Bowler 1 and Bowler 2. Okay, they have very similar shapes and distributions. They're both unimodal. Okay, they're both roughly symmetrical. Their centers are both around 150. Okay, if you find their means and medians, they'll actually be very close to one another. But you can see that how far apart their spread is very different, right? The variability is quite high to the Bowler with number 1, right? Has much higher highs and much lower lows, whereas Bowler 2 stays into a much tighter area there. Okay, and when we use what we're going to use to do that, okay, has to do with quadrants, okay? And we look at that because consistency is so important when we're looking at athletes, okay? Just being able to consistently depend on that athlete to perform at a certain level, most coaches would rather have than the feast or famine guy, okay, who goes out and shoots, scores 35 in a game or scores 2 in a game because he either misses everything he shoots or makes everything he shoots. Most coaches would much rather have just a consistent guy who scores that 10 to 12 points in the middle type of thing. Okay, so, and as I said earlier, we're going to look at quartiles and we're going to look at the range and interquartile range then to be able to determine that. So range is something hopefully you've seen in the past. Okay, you just take your largest value and subtract your smallest value and it tells you the total spread of your data from one end to the other. What does it look like? Okay, so for the American League, you can see here it's 361 runs, and in the National League, it's 271 runs. That's quite a big difference, right? That's a difference of 90 total range. So that right there, right, is a pretty good indication, right, that our National League distribution is much closer, right, and our American League is much further spread out. It can be a little deceptive though. Sometimes, right, you get that one value and it's called an outlier. We'll talk about that in the next lesson. Okay, that really pulls that range one way or the other. So sometimes it's a really good idea to look at a second measure of variability, which is simply the interquartile range. And what that focuses on is the middle half of your data. So it ignores the values at the very top, it ignores the values at the very bottom, and it looks at just that middle half of your data. So to do that, we have to find quartiles. So that's where we have to start. So we're going to go back to those 2019 AL teams and their runs scored. Okay, and again, these are already in order from least to greatest, and we're going to find these quartiles. Well, the first one that we're going to do is find the median. Well, the median is actually Q2. So that's something we've done before. We know this median halfway across is 769. Okay, because we figured that out earlier. But now what we're going to do is find Q1 and Q3. And to do that, okay, we have to look at the two parts of data that we now have. So we have our lower half of the data, we have our upper half of the data. So if we look at our lower half of the data over here, we 582 to 769, and we find the middle term, and voila, right there, we're at 726. And just like with the median, if there are two middles, you add them together and divide by 2 to find the average. And then we're going to do the same thing on the top. Okay, we add the two together, divide by 2 if need be. This particular time, we don't need to. It's an odd number. And we find that 901 is our third quartile there. So now if we're looking for the inner quartile range, so what's the range from Q3 to Q1? Or vice versa. Okay, then we just simply subtract Q1 because it's the smaller one from our larger one, which is Q3. And in this case, we get that the range is 175 runs. Okay, so I'm going to give you a second. Go ahead and hit pause. Okay, and figure out what Q1, Q2, Q3 in the inner quartile ranges for the NL. Okay, hopefully you've figured this out. You unpause it, and now we're looking at this, right? So our median is right there at 774. Q1 was at 701, and Q3 is up at 835. So when we want to find the interquartile range, we just simply have to do 835 minus 701 and get that that's a difference of 134. So if we look back at those two values, right, because we said the overall range was spread out further for the American League than it was the National League. And indeed, the interquartile range is also spread out further, right? So we definitely have a good amount of evidence that says that the NL distribution is much less variable than the American League distribution is, and that the American League distribution is significantly more spread out than what the National League distribution is. That's all we've got for you today. Hopefully this was helpful and you enjoyed it. And have a wonderful day, and we'll see you back next time.